All right. Now, if you weren't careful with this problem, you would probably go a little insane. Suddenly, I have somebody interested. Let's see. 96. This is the one we're talking about, right?
Yeah.
Yeah.
Okay.
Now, this problem is not impossible to solve by hand, but it's pretty damn close. Yeah.
It says there's a graphing calculator up by the numbers.
Yes, cool. Look at that. Again, it's like you're in my brain. So if you're not careful in this problem and realize that there's a little symbol here on the graphing calculator, what they intend for you to do is solve this graphically, right? In fact, the instructions say to do it that way. So how the hell do you do that? What is the idea graphically for the solution of an equation?
Where they intersect.
Where who's what?
Wherever the lines intersect or whatever. Parabola. Where they intersect. Where there's two different.
Yeah. So if you graph this thing, what's it going to look like? Sweet.
To the left one.
We graph this thing, what's it going to look like? That. So if you have that and that, they might meet someplace, and of course that's what that equals means visually. Visually, that equals means where's this graph the same in the same place as that graph? So where do they meet? Cool. So let's do that. Which one are you? So many options here. Okay, we'll let that guy speed up. So if you haven't used the graphing calculator much, you have no idea what to do. There's a little y equals button up in the upper left-hand corner. So you have to make an L so I know which way is left. Upper left-hand corner. So if you hit that y equals button, you can input functions. There you go. Cool.
All right.
So hit that y equals button. There might be other stuff in there. Take all the other stuff out. So one of these things is square root. So if you hit the second button, that's like your shift. Second. Alright. Don't want to. They're pinging us. No excessively loud noises. It's the hunt for Red October. That was actually kind of cool, huh? Square root of x plus 4, let that be y1. That's our first side. And then the other side. Now, the newer calculators, if you have a newer calculator, the square root symbol will extend. If you have an older one, it just opens up parentheses, so you don't want to close it until you got everything in there that's under the square root. You with me? So I don't know where you guys fall on that spectrum of age of calculator. X squared. No, Jeff. X squared. No, Jeff. Get out of there. Clear. X squared minus 5. That was much harder than it should have been. Alright, cool. So now if I graph this, let's see what I get. I got some leftover weird-ass window that somebody else was doing stuff on. So whenever I put new functions in, the first thing I do is I hit zoom 6. Beautiful. That brings you back to what's called a home screen. -10 to 10, -10 to 10. That might not be good enough, but it's a really damn good place to start. I can just barely see somebody down there. So if I hit zoom, and you see all this other stuff you can play with. Zoom box we're going to use a lot. Zoom 6. Yay. So then I can see my two answers. Right. So I can approximate them. That's not good enough. I want to know exactly what the hell they are. So how do you find that negative answer? Good. So let me make sure. Everybody playing along with me, or to this point, can you see this on your screen? If you're playing along with me.
No, can you go all over again? Like from the beginning, sorry.
So you got the y equals, you got the functions in there.
Okay, yeah.
So now I hit zoom.
Okay.
6. And this should happen. How's that? Is that good? Okay? Yes. Oh, good. Let me see. favor, hit zoom. 6. How's it doing now? Is it okay? Good. All right.
Saying that there's two places for
I love it. So this equation happens to have two solutions. And I can see that visually. There's no way that they're going to meet again after those two meet, right? Now, if I had some weirder functions, I might have to go off window to see maybe they meet somewhere else. But they're not going to meet again. That guy's going forever that way. That guy's going forever that way. They're not going to meet again. So there's only two answers.
So how come the other one looks like the parabola is sort of horizontal, but it looks like this little line right here?
Oh, all right. So this, obviously, this piece here is which side in the equation?
The right.
That's the x squared minus 5. That's the parabola. And of course, the square root is a parabola that's fallen over. It's the inverse of a parabola in a way, as long as you kill one of the sides. Right? Does somebody remember what has to happen to have an inverse? It's got to pass a horizontal line test. So a parabola obviously does not, you with me? Does not pass a horizontal line test. It goes through more than once. So you actually have to slice half the parabola off, and then it does work. And that's why a square root is a parabola that's fallen over and lost its bottom half. Right? Either a rough time or a good night, whatever that. Right? Lost its bottom half. Poor little dude. So how do I find this answer right there? Yeah, go to second, trace to get up to calc. So basically everything up here is all about graphing. So if I want to calculate something on my graph, I go to second trace to get into calc. And which one of these sounds like it might be? Yeah, I want to know where they intersect. You can also find you can input an x value and see what the output is. You can see where they're 0, where it hits the x-axis, right? You can see the min-max. But the last two are calculus stuff. Oh, yeah. So we won't use that at all. Let's see, number 5 for intersect. Just to get straight to the point here. How many curves have we put in?
2.
So what it does is it's going to ask you 3 questions. It's going to say, what's your first curve? You hit enter. And it's going to bounce to the next curve. And it's going to say, what's your next curve? And we've only got 2. So we would hit enter. And then it's going to say, what's your guess? And then you put the cursor on top of, as close as you can to the answer, and you enter. So what you do here is you just put your cursor there to begin with, right on top of the answer you want, and go, enter, enter, enter. Because it kind of answers the first 2 questions by itself. You only have 2 curves. You hit enter, it's the first curve. It moves to the second curve, enter, and then it asks you for a guess. Well, you're there from the beginning. So what's one answer to this equation?
Negative 2.495 approximately.
Yeah, cool. So you can approximate it, because I don't want to write, obviously, it goes much further than that, right? But that's fine. And then you do the same thing to find the other answer. You only find one answer at a time. I think on the Casio, it's able to find more than one answer at a time, but I don't know. I haven't really used them at all. How do we feel about that? I mean, if you've never seen this before, that was probably a little bit quick. Okay, cool. All right. And if you guys could help me and remind me, it's my fault.
I was asking you if you wanted me to do that. I didn't know if you...
No, it's my bad. I didn't hear you. All right. For those of you at home, that's what it looks like. All right. Yay. Okay, cool. So is that good for that problem? So there's one more answer. You guys can do it now. You can try it out, see if you can do it on your own. Yeah.
Can you do 24?
Oh, okay, yeah.
I don't know why.
I know your question. Remind me, guys, what's the square root of x squared?
X.
No, you're wrong. No.
There's nothing, you can't.
The answer to a square root question, in fact, let me ask you this way. What's the answers to this equation?
3.
Plus or minus 3, because there are 2 square roots for anything. But when you see this symbol, it's the positive root. How do I know that? Because there's a plus sign there. If they wanted the negative root, they would have had to put that there, right? So if I see this, that's the positive answer to this. If I see that, it's the negative answer to that. So any square root, the answer must come out positive, by definition. So if you say this, and x is negative, and you don't want to say plus or minus, because again, how many answers is there to a square root? 1. So if you put plus or minus x, you got
2.
That's neat. So of course, what function makes something positive?
Absolute value.
Absolute value. So if you have square root of x squared, y,
Y to the fourth.
4,
Then it has to be both.
of course, square root just cuts things in
Half.
half. So it would basically be xy squared. You wouldn't be wrong if you did this, but why do you not have to do that?
Anything squared is positive.
Because y squared is definitely already positive. But if you did that, I'm cool with it because it's not wrong. But you only really need to go there.
Okay.
Is that cool? So what's the square root of m6?
Absolute value.
Absolute value m cubed. Correct. Like, what's the fourth root of x to the 8th? X squared. You don't need an absolute value, right? 4 goes into 8 twice. Cool. Thanks.
So you only really need absolute values on odd.
Exactly, because odd exponents are the ones that allow negatives to still happen. Good.
That's the only one I can't completely miss. The other one I know what I know.
How are we doing so far? Is that cool? Is it starting to come back? Does this sound familiar? Hopefully it does.
Slowly but surely.
Slowly but surely, okay. All right. Anything else from homework? Yes, ma'am.
Number 9.
Oh yeah, that looks funky. Let's see. So 9 has like nested absolute values, right? Where are absolute values in the order operations?
In the beginning.
Same as parentheses?
Same as parentheses. They're basically parentheses that have one extra job. Not only do you do inside first, but whatever the hell it is in the inside, you make it positive. That's the last thing you do, right? Parentheses don't do that kind of crap. They just kind of go, do inside and then I'll go away, right? So I don't worry about these yet, because you got to figure out what the hell that is. And of course, what do you do first in here?
Make that positive.
Yeah, the absolute value negative 9 is 9. And I always get somebody tell me this is 3 plus 9 is 12. Why is that not right? Why did that person do that?
Because they did the minus.
Yeah, you pay too much attention to the minus sign and you think, oh, it makes everything positive, but it makes any number inside of it positive. Do I know what this number is yet? No, so I can't do anything to this yet. You kind of with me? So of course 3 minus 9 is
6.
negative 6, and the absolute value is 6. So it's definitely not 12. Cool. Okay. So I don't know if you picked up on this yet. I have no problem going back and talking about whatever the hell has bugged you for the longest time about mathematics. If anything's bugged you, you don't know why the hell it works that way. This is the time to get it out there, because after chapter 1, I'm going to assume we're all cool with everything in chapter 1. Yeah.
Number 46.
Oh, yeah.
The cube.
All right. If you haven't done this one yet, do it. And you just hang out. You're like, I tried, man. If you haven't tried this one yet, try it. Let me help you out.
I know what I did.
What kind of form is it in?
Cube.
Yeah, it's only 2 terms, so it could only be squares or cubes. It must be cubes, because there's a 3 there for one thing, right? There's no GCF that might change it to a squares or something, right? So the minute you know it's cubes, what do you put down for yourself? Little dude?
Big dude.
Big dude. I like it. And you've got to figure out what goes in where.
Yeah.
actually did that the first year I was videotaping. The whole thing was like an MC Escher thing through the water. All right, so either you got it or you're just waiting for me. Like, come on, dude.
2x is y squared.
Yeah, so this is 2x, 2x, 2x. This is
Y squared.
y squared, y squared, y squared. You just cut it in thirds. So little dude's a little dude. He gets one of each, and the sign is the same. And then, of course, the big dude has to get the other 2 to make 3 at the end. So he gets 4x squared, and at the end he gets y4. So you can see everything that you want. But you see more than you want, so then the cancellation dude comes in. He must be
Opposite.
minus
2x y squared.
2x, y squared. Cool. So that's the cubes is one of the more hated factoring forms. But to be honest, it's actually one of the easier ones. You just got to realize you can't really work it. You got to just remember where things go. 1 of each, 2 of each, product in the middle. Right? And again, that's the closest I get to saying that in. Yeah.
Could you do 33?
Oh, yeah. And real quick, let me show you. Sorry. Well, again, I said real quick a little too soon. Go on Firefox.
Do you want me to turn the camera?
No, don't worry about it. Thank you, though. So up on the website, under Math 176, you see now there's factoring guidelines. So you can go there and print this out. There's the little quick reference up at the top. And then there's very detailed explanations of each down below. Right, so if you're trouble with factoring, that's where you can go for it. I put a word problems handout that I give to my 9103 students. So if you want to take a look at that, those are the basics of setting up word problems. Our problems are going to be a little bit harder to algebraically solve, but the steps you use to set it up are exactly the same. So that still applies. Let me think. I think there's one more. Oh, there's the TI calculator guide. Right.
Whoa.
How come you didn't give us this last semester?
What's that?
How come you didn't give us this last semester?
You were with me in
Summer.
110.
Yeah.
Yeah. Oh, because I'm a jackass. No, I don't know. I forgot I had it, I guess. Sorry. You made it through somehow.
I don't know how.
So your question was number 33, right? Yeah. So you start to realize there's a certain look to things. This is just loaded with a lot of the same kind of stuff everywhere. But even beyond that, what do you always just try first?
GCF.
Yeah, so this has got a lot of common stuff here. So what number can you take out?
3.
How many x's can you take out?
X. 1.
Yeah, you always look for the lowest. Because you're like the kind of fair tax dude. You're not going to take 2 x's from this guy because he didn't have it. Right? The actual tax people in Jewish. So 1x, and then, good, y squared. And then you just write what's left.
4x y squared.
4, you had 2, you took 1, you had 4, you took 2, so forth. Right, is that cool?
Mm-hmm.
This way.
Why would it be y squared? Why is it not just the y by itself? Because from the x you just took 1.
If you only take one y out, do you see how they would all still have one y?
Oh.
And you want to take out everything you can so that nobody has anything common left. You with me?
Yeah.
Okay, cool. It sounded like an evil plan for some. It's like everything away so nobody has anything in common.
Perfect.
Somebody else? Yeah. But did you have a question with this? That kicks ass. All right, 63.
So then, is there nowhere else you could go on 33 right there? After you write.
Yeah, well, let's finish this out real quick. So you get 3 there, and you get...
3x squared.
So this guy's got no x's, this guy's got no y's, this guy's got no numbers. So there's no possible GCF left. So if you would have taken out 1y, you would have seen that everybody still has at least 1y, and you go, okay, I got to do one more step. take out one more y.
I thought that was
No, I
still
got
had to do, that's why.
So what's that?
I thought I had to keep going in that step, so.
Oh, I see. So let me put it back to where it was. Let me see. We had 2, 2, 3, and that's gone. Yeah, that's definitely not in the right form
Yeah.
for trinomial kind of stuff, right? Okay, good question. There's no way in hell. For trinomial to work, if it's x to the 6th there, what's got to be in the middle for this to work? Some kind of x to the 3rd kind of thing, right? It's got to be half of this, because the first thing I do is I cut this in half. And those are what's going to build the middle term. So that's a cube for one thing. That's a square you'd be like in front. And then this weird, that's not going to work. There's no way that's going to go anywhere. There's a good. You got to make sure that it's not going to go anywhere. Yeah.
Can you group from there? Or?
No, grouping requires 4 terms, and it's not even in the right form to do the surefire, the 3 times 4 or whatever. It's not the right form to do that. Cool. So that won't go any further. 63.
Yeah, the square root of x
Fashion.
over
Square root of 6
06.
over the square root of 3 plus the square root of 2.
That's all right, man. Don't worry.
And rationalize.
Man, they all had no.
Rationalize the denominator.
Oh yeah, okay. So if this was just square root of like 7 over square root of 3, how would you rationalize the denominator?
Give
Three
it
over
square root 3.
You'd multiply by square root of 3. I love it. Why?
Because that's what it needs to become whole.
I like it. So I call this completing the root. The root needs 2 things because it's a square root, so it's got 1 3, you give it 1 more 3, right? So I would just multiply by square root of 3. If it was the cube root of 3 on the bottom,
You multiply by
3 by 3.
2.
how many 3's does it need?
2.
Oh, 1.
It needs 3, so it needs 2 more. I love it. So you multiply by cube root of 3 squared. You don't just multiply by whatever this is. You multiply by what this needs. Right? It's only got 1 3. It needs 3 3's because it's a cube root. So you just multiply by 2 more 3's. It's almost too easy when you realize that's how you look at it. Now, the minute they make the bottom more than 1 term, that's not going to work. Not directly. So what I need, if I multiply by root 3, this is still a radical. If I multiply by root 2, that's still a radical.
Yeah.
So I need to multiply by root 3 and root 2, but I need to do it in a way that the middle term cancels, because that's the only place a root would still exist. Good. And what's that called? I think I heard something. Beautiful. That's the conjugate of that. I love it. All right, so you multiply by the conjugate, top and bottom. Because now this looks like what kind of factoring form?
difference of squares.
Difference of squares. It's going to lose the middle term. The middle is the only place a radical could have survived. And you're killing it, right? So root 3 times root 3 is?
3.
3. Good. Blah, blah. Middle term cancels. Root 2 times root 2 is? 2. It's crazy. What do you get on top?
Root 18.
Rad 18 minus rad 12.
But you can simplify.
Good. So the bottom is 1.
Oh, God.
You guys kind of with me still? What can you do with rad 18? Can you do anything?
You take a
Good. 18
3
is
out
9
from
times 2.
Cool.
And rad 12 is
2 rad 3.
4, 3. I like it. So you get 3 rad 2 minus
2 rad 3.
2 rad 3.
Oh,
Rad. This is a word from my youth. It's still out there.
is that why you became a math teacher, so you could still use rad?
Pretty much, that's it. That's it. I said I'll make up the rest of it. They won't know. Oh, shit. Yeah.
Can you do another one? 78.
Sure. Okay, good. You guys are all like, let's just keep asking and they'll do the whole thing for us. So I'm on to you. 78. This might be the last one.
Is that right? Or not? Look at you.
Yeah.
Yeah. Now the only thing that really throws you off this problem is the powers they chose. But is it the right form for me to try to factor it?
Yes.
Because the middle power is
Left.
half the first. And that's what we call quadratic in form. So if I try to factor this, x4 would be,
X
that's going to give me the right middle term variable piece. Now I just got to figure out the numbers over.
minus 9 plus 1.
Yeah, so it's going to be minus 9 plus 1 to make this a negative 8. And they don't say here. Oh yeah, they do. It says find all real solutions of the equation. So you can kind of let which piece go. Yeah, this is not going to give me any real answer, so I can just focus on this. And of course, this goes.
Minus 3. And then you can break that down.
So then I get.
Yeah, but you 3.
Negative 3 and
3 and negative 3.
Done.
No.
Done, because the instructions say find all real solutions. If I said find all solutions, this is not good enough. What are the other two solutions?
Negative 5, negative
No. Because it's a plus. You can't factor this over real numbers.
Yeah.
You could factor it over complex numbers. So x equals plus or minus I, but you don't have to put that down. If you do, I'm not going to count it wrong, but they did say just find all real solutions. How many total solutions are there if I count every possible solution? 4. And what was the power on the original? 4. So if it has an 8 power polynomial equation kind of deal, it's got to have 8 total answers.
Anytime you have to have the amount of solutions to the power.
Yeah, so if this was an 8th power, I should have 8 total real and complex solutions. Right? And why does that make sense? I mean, what does that power have to do with what the graph looks
How
like?
many times it crosses the x-axis?
How many?
Less specifically, how many times it turns around. Because you could have a polynomial that does this and it just only goes through it way down there.
Okay.
So yeah, so a 4th power is going to actually turn 3 times. A square does this, it turns once. So that's why I can have 2 answers, because it could do this, right? So a 4th power would turn 1, 2, 3. So it could have 1, 2, 3, 4 answers. Now it could have fewer real answers because maybe one of these doesn't actually go there. Maybe one of these goes like this. So to have 2 real answers and 2 complex answers. Because in the real plane, that never hits. In the complex plane, it does some weird shit. But it shows you why it's some more answers. Yes, ma'am.
John, can we do number 99?
Okay, anybody have anything else about this here?
Okay, you know how sometimes we get answers that don't work out?
Yes.
Would that still apply with there's that many answers power?
So a situation where you get an answer that doesn't work out would be a rational equation, right? Where the made the bottom 0.
No, I mean, like, if you said that there's the number of powers are, the number of solutions are.
Beautiful. So what I'm trying to tell you is if it's a polynomial equation, what I said, that's what I said. I said if it's a polynomial equation, the degree tells you how many answers you're going to have, period. Never will it be different. You will always have that many answers. The only times you have answers that don't come out to be true are when you have a radical, that's not polynomial, or you have a rational expression kind of thing, and that's not a polynomial. Do you see what I'm saying? So it's a really good point. You do have stuff to get a throw away. But it only happens when it's not polynomial, when it's something freaky, where the equation freaks out somewhere. Like a radical or a rational. Okay, good. 99? Right? Oh, okay, yeah. This is that crazy amount of steps problem. So real quick, let me not do this whole thing. Let me give you what you need. Part A, if you can't do that, just leave. Part B, the distance between 2 points. Somebody remember what that formula is and what it's based on?
It's based off of Pythagorean theorem.
Yeah, it's based off of the Pythagorean theorem because to find the distance, you just have to get the hypotenuse of that little triangle you would make. And this is the difference in the x's, the difference in the y. So you get
Squared plus squared.
it doesn't really matter what order because you're squaring, so it's
Second.
but yes. The midpoint and the middle of 2 numbers. If I said what's in the middle of 2 and 6, you could just average them, right? So the really cool thing is if I have a point that's 2-dimensional, I still do the same thing. The midpoint between these 2 points is just the average x, comma, average y. So if I ask you for the midpoint, you take the average of the 2 points. You average the x pieces and you average the y pieces, you're done.
Yes.
Right, so visually, the average of the x's would be about here, and the average of the y's would be about here, so that point there would be the midpoint. Hey, that looks like it's about right. Okay, good. All right.
The circle was great.
You guys really should get into playing poker, I think. You don't need glasses or anything.
As long as we can listen to you on a podcast.
Yeah. Okay. Is that cool for 99? Let me see.
You still got circle and slope intercept.
Sketch the line determined by that and find its equation. The slope intercept formula, that's easy, right? Hopefully. They give you 2 points. Now, I feel comfortable saying that's easy. If I gave you 2 points, you should be able to find its equation. Find the slope. And then you could use this guy, or you can use, what's the other guy?
Y minus y1.
Equals x
M
minus x.
That's right. M is y's over x's. So all this equation does is pull the x's up. It's the same damn equation. If you've ever never noticed that, that's what all that is. Okay. And then part E says, sketch the circle that passes through Q and has center P and find the equation of the... Ooh, I like that one. That's the one that looks most disgusting. So I think A through D, I'm going to say I've said enough about those.
Once you figure out D, it's pretty easy.
Yeah, because D has got
The distance.
sketch the line and find its equation. Well, no, it's part B. Is that what you said? The distance, yeah.
Yeah, the distance gives you the radius.
Exactly. So in part B, you look for the distance. And since this circle is going to be like this with that as the center, that's really good for me. This is the distance, in which case for part E, it's going to be the radius. And you got the center. The center is this is that point they gave you. So then you just got to fill it in. So from part B, you've got the distance, which we realize is the radius. Throw that number there. And that point is the center. Throw those pieces there and you're done. Sweet. Okay, maybe. So when you learn lines, when they say find the equation of the line, that does stuff. You know to find the slope and the y-intercept or some point. If you get those, you just fill them in. So if I say find the equation of the circle, that does some weird stuff. You say, okay, I just got to find the radius and the center, and I can fill them in. And I'm done. Yeah.
You go to number 42.
Well, we have another one before that.
Oh, I'm sorry. 30. 30 and then 42. And then that's it. Because that's getting dangerously close to all of them.
Yeah. It's like the 6th time I've done that. Anytime it turns.
I think we should just pick one section.
Can you go over all of the section 2
All right, guys. So how do I write this? What notation is this?
Scientific notation.
Good. And where do you use this?
Science.
Science.
That's amazing, isn't it? Gives it away. So in astronomy, you don't want to say the star is so many billions and billions of miles away, unless you're like Carl Sagan or Neil deGrasse Tyson. But we want to be able to capture all those zeros without having to write them all down. So this is basically where we keep track of all the zeros, right? Multiplying by something to a negative power is the same as dividing, because those 8 tens would come down. That's why this number comes out small. I have problems with left and right. I just do. I get too much other shit in my head, I guess. But negative power makes it small. So I don't have to know what direction that is. I just know I go that way to make it small, right? Positive power makes it big. So I go that way. Whatever direction that is. So I just got to go 8 back. And the beautiful thing is, you got to go once to get around that stupid 2 there, right? So then how many zeros would there be in front of that? 7. There you go. Done. So you got point 1, 2, 3, 4, 5, 6, 7. Done. All right, put the little safety 0 out front. If you've done any science, anybody done ever any sig figs? Remember sig figs? Does this sound familiar? Aren't those fun? No. Aw, it's too bad. If they ever taught you about what zeros are significant or not, that's a stupid way to teach about them. So much, I have 2 rules that get you through all sig figs. But I'm not teaching science, so it's all right. All right. Sorry, science teachers, if you teach more than 2. In case anybody actually watches my videos. 42? Was that the one?
Yeah.
All right, this is the last one.
Oh, it's perfect.
All right, so any GCF there?
No.
No.
No, but you can group.
Totally. I've got 4 terms. You always look to see if there's a GCF first. If there's 4 terms or more, you group. So the first way you try to group it is there and there. Don't draw parentheses in, because then you got to be careful with the negative and all that kind of weirdness. Just underline. I want to do these 2 and those 2. So what comes out of these 2?
Y squared.
Y squared. And you're left with
Y minus 2.
y minus 2.
So those are Y minus 2.
Now you know this guy's got to be the same as this
But
guy,
it's got a
or else you
negative.
can't do the last step. It's a negative y currently, so you have to take out a negative 1. And then all the signs change inside. So thank God these are the same. I love it when people get here and they still manage to do the next step. I'm like, whoa. You cannot. The next step says take this out because it's the same. If it ain't the same, you can't do the last step. Yes, sir.
What would it look like if you had 5 different,
So with 5, you might have to group the first 3 and then the last 2. So it gets more interesting when you have more terms in there. Yeah. Let's see. So now what's the next step here? I can take out a...
Y squared.
Okay, I can take out a y minus 2 and there's a y squared minus 1.
Squared.
What happened? Wait,
No.
let me make sure I understand. There's not 2 y minus 2s. There isn't. And of course that's where people are wondering about my mental health. But there is not 2 y minus 2s. There's one that somebody distributed to both.
But now you have a different.
So when you take this out, it's not this. There aren't 2 of those, right? There's one that got distributed, so I'm just undistributing it. You guys with me?
Yeah.
In fact, the highest power on the y is 3. What would the highest power be if I multiply these out? 3. If you had this squared, it would be too big. So that's telling you right there it's not quite right. Now, of course, am I done?
No.
No. Why not?
You have a different square.
I love it. So that'd be, we all know that one. Cool. So let grouping be easy, right? Most of the time. It can get a little freaky when you have more terms than 4. Okay. So I want desperately to finish out chapter 1. And let me see. Last time we were in the word problem section. We sort of were doing some word problems. Let's see. Let's try a couple of those before we move on. Oh. Whoa. Is this it? No? That doesn't look right. There's one. That'll help out. Oh, here it comes. Okay. So I'm going to look on page 70. Whoa. Let's try number 72. Uh,
70.
yes, 70. Too evil. Remember, we identify this as a distance rate time problem. So we can put this down. And we got, so this is Tortula to Cactus, and then from Cactus to Dry Junction. Yeah, that sounds like a great trip. Okay. Yeah, so we know from to Cactus it was a distance of 250. And from there to Dry Junction is 360. So you always look for those definite numbers you can just throw in. Now where do I go from there?
The rate.
The rate is X.
Good, especially because this question is about the speed. It's a good idea to assign that a direct variable. So what was her speed from Tortula
X.
to Cactus? I don't know, so it's X. And of course then the speed here would be
X plus 10.
X plus 10. Kick ass. And then you don't search for that, you can fill in. And the minute you got one box left, you don't look here anymore. You look here for the formula. How do you find this?
250 over X.
Beautiful. Distance is rate times time, so time is distance over rate. So distance over rate, distance over rate. And now you use that thing they said about the time.
11 hours.
Yeah. So this time
Plus.
plus this time has to be 11. Cool.
So are we going to end up with three equations?
No, that's it. That's the one equation.
Oh, okay.
See, this information they gave us built an expression for time, and time is what they restrict here, right?
Right.
The time must be 11. That's where the equation comes from. All the other information is just so I can get an expression for time.
So it's both of them together that equals...
Exactly. As a total time, total trip took 11 hours.
They wouldn't equal to each other since they're both, each one is 11 hours, or is it...
No. It didn't say each leg took 11. The total trip was 11. So the amount of time it took her to get to Cactus, plus the amount of time it took her to get to Dry Junction, is 11 hours. And I don't know how much time either one. She was going faster here, but there was less distance here. So I don't know exactly how much time they each took. Right? So I can't try to assign a number to it. So how do you solve this equation here?
Is it?
Yeah, I have one color today, so it's too bad for everybody. So what's he missing? He's got.
Oh, okay.
And he's of course missing. And he's missing
Everything.
everything. I like it. So then here I get. Oh, don't do that, Jeff. You're silly. You're exactly what you're not supposed to. So here I can kill these, right? Because now I can multiply by that denominator. Bam. So if you get all the denominators the same, the next thing I can do is multiply by that thing, because then it kills it all. And then I don't have any fractions left. I got a nice one-line equation. So I get 250x plus 2500 plus 360x equals 11x squared plus 110x. Big mistake. People forget that x. Both of this has got to go through to both of those. Yeah. And of course, here I have to do what? Get everything on
One side.
one side because of the
Equal sign.
squared term. I've got to get everything on one side, try to factor it. That's how I handle when there's a higher power on there. Okay. So then I get 11x squared plus 110 minus 250, so minus 140x, right? Minus 2500. Oops, I forgot my 360.
500.
So minus 360. So 11x squared minus 500x minus 2500 equals 0. That looks yummy. So you need factors of 11 times negative 2500 that add up to be negative 500, right?
You guys with me? Where to get that from?
I'm just gonna throw it in quadratic.
At least we should try this. If I wanted to factor this, if on a test your evil instructor said, solve this by factoring and by no other method, what would you have to do?
Are you that evil?
Oh, hell yeah. So 11 times that, because that number's not 1, so I got to take it into account.
27,500.
What? It's huge. And he factors of this to add to be that, right?
That's exactly
You guys are funny.
So 50?
So real quick, stay with me. Why is this sort of equivalent?
Because it is.
Because it is.
This is crazy.
Because you're just dropping your 2 zeros.
Actually, it would have to be, well, this, you'd have to be careful there. So you can figure this out. And in fact, what I always tell my students is if you have an evil instructor like me, and you don't start with the factors of this, you start with things that add to be this. So for example, 1,500 and negative 2,000 add to be this, right?
Yeah.
Well, what's 1,500 times negative 2,000?
Not that number.
Nowhere near, yeah. So maybe, like you just said, maybe it's negative 1,500 and 1,000. Maybe that's closer.
No.
Nowhere near, right? Okay. So then you keep going. So maybe it's negative 800 and 300.
I don't think it's possible.
And maybe it's not possible. It's fine.
The
No.
point is we try.
That's
Good. The point is we're trying, right? So what is this come out to be? Negative 24,000?
no. Sorry.
Yeah, it's still way too big, right? So then maybe screw this. All right. So you can throw that into quadratic. I'll bet you this works. Let's see.
It's not going to come out.
Oh, now he's gonna definitely do it.
No, it's not good.
Does it come out nicely when you put it in the
So
quadratic?
it's got to be something like negative.
15.
Could it be
515.
Like negative 5 would be 25.
Yeah, 515.
5. It's way too small. So somewhere in the negative 500 something.
Sorry, negative 550 and 50.
Negative 550 and 50.
Yeah.
Cool. All right. I like it. But you could certainly use quadratic, right? I never claim my brain is a calculator, so calculators do help.
So now can you show us the table that you can put it in so you can find that on the calculator?
What do you mean?
There's a way to do that where it'll tell you what. Never mind.
I don't think my calculator.
Not that I know of.
There it is. My geometry professor's always talking about it.
All right. Track
But
them
I
down.
can't remember how to do it. I will. I'll email that.
So it'll make there's a way to make a table of all the
using
factors.
Yeah.
Cool. I didn't know that. All right.
You said you knew about it last year or last semester.
No, I would never claim to know that because I don't.
He probably just didn't understand your question and said yes.
Yeah, that happens.
Oh, then how would you factor in?
Oh, well, if you keep going this way, you would eventually get here,
Yeah.
right? And then you'd have to break up the middle term using these. And then just group. And once you figure out these two numbers that work, the rest is easy. Break up the middle term, group. Grouping is always easy. This is just GCF a couple times. Right? Now, if you just threw that into quadratic formula, I would not be overly critical of you, right? Unless I did say you can't use quadratic formula. I might be that evil. Okay. So let's try one more, and then we'll see what time we got left. Let's do one of these tricky ones here. There we go. Well, I like it. Let's do number 59. That looks nice. Ooh, that looks evil. All right. Just try something.
Which one?
59. Yeah. I think Jill's a little bit OCD. I don't know, you guys. I will not drink this. It's 48%. Let me help you guys out just a little bit, because it sounds like there's more to this than there really is. So you drink some of it, but just pretend like you start with how much?
750.
Yeah.
650.
Now you start with 650, 50%. She adds 100 of X percent. I love it. So she ends up with 750 of 48%. I like it. So that's the real quick rundown of the main part of this problem. Right? So she adds this to get this. So the way you do this, so again,
Multiply across and make the equation.
I love it. So one way to do this is to make this big old chart. It's sort of like the distance rate time thing, but then there's going to be 3 parts to it. It's going to be a bigger chart, right? Thing 1, thing 2, and mixture. So I got, in this case, I've got the 50%, the unknown percent, and the final mix, which is 48%. So there's an amount, a percentage, and this thing I just call it the solution. I don't know what the hell else to call it. So the idea is this. How much fruit juice is in what she starts with?
50.
How much? Not what percent, how much?
750.
No.
50.
325 milliliters is of pure fruit juice. You guys with me?
Mm-hmm.
If she's got 650 milliliters and it's half pure fruit juice, and how much pure fruit juice is there? 325. How much pure fruit juice is there? Sure. X, I love it. Kick ass. X percent of 100 is X. So if you add those two, if you add how much pure fruit juice is here to how much pure fruit juice is here, it better be how much pure fruit juice is there. I'm trying to say pure fruit juice a lot. Yeah. So this kind of shows that idea. I've got 650 of that, 100 of that, so of course I'm going to end up with 750. I've got, so this is 0.5. This is X percent, so I can kind of, maybe I should just call it X percent. Let's call it X. It's going to come out as a decimal. I can make that into a percentage. That'll make it easier to work with. You guys kind of with me? And then so this, 0.48, I love it. You can never just add rates to get someone, obviously they're going to kind of average out somehow based on how much of each. So be really careful about making this too simple. But here they just told me what the hell it was. They got, so here, like the man said, multiply across, and it only makes sense because half of this is how much pure fruit juice. So half of 650, 325. X of 100 is 100x.
That's 360.
Where am I at?
The bottom is the bottom column. The bottom row.
750.
Oh, thank you. So 40% of 750 is 360? All right. I like it. You're trying to be helpful, but I didn't know what the hell you're talking about. I was about to ask you that, and then you're like, what? So then you just follow exactly what we said. You take these two, you add them to make this. This plus this has to make that. So from that ugly problem comes this beautiful little equation. Of course, what do you get there?
0.35.
35%. Good. So 0.35 or 35%, which makes sense because I started with 50%. So this has to be less, so you dilute it down to 48%. So 35% makes sense because I don't have much of it. So it's got to be a really low percentage to break it down to this. You guys kind of with me? Okay, good. So these kind of problems you've seen before, like they mix antifreeze or they mix saline solutions, a nurse mixes saline solutions, or they do stuff like that. Same idea, right? You can even put money here, like the raisins and the nuts problem the other day. So the amount, and then the price per pound, and then the total price here, and it works exactly the same way. So any kind of mixture problems you could do with this kind of chart here. Cool? Okay. So I think that's enough of that. Let's see. Have I left myself enough time? I'm asking myself, by the way. I don't want you guys to answer the question. You're like, no, Jeff, we have to go now. So I'm not going to spend any time really. Well, let me take a step back. I will spend a little bit of time on something in section 1.7. Part of 1.7 is just the basics of inequalities. The book and I don't agree, and I forgot that this book does this. It's funny that our Math 103 90 book graphs things the correct way with those symbols, and then this book suddenly brings back the circle. So screw that. I don't care what the book says. I told you to use this. But here's something. Let me see if you guys remember how to do this. How do you solve... You said it. Sorry?
So that greater than 0, you take each part?
Nope.
Wait, no.
That's not the only way this can work, possibly. So you gotta be really careful. I can't just set each piece greater than 0, because what's another way some product could be greater than 0? Maybe all the pieces are negative. So there's more than one case. So the most direct way to do this is to realize this is asking you, when is this product positive? Really, right? So then you say to yourself, okay, what's the dividing line between positive and negative?
0.
0. So where is it equal to 0? And in between those are going to be my answer. Because when it hits 0, it could change from positive to negative. You kind of with me? So if I can find where does it go through the x-axis,
0, 0.
or maybe it turns so it stays positive. I've got to see if it's going to be evil like that. I can figure out where overall it's positive. And stick with me. Some of you guys are like, shaking your heads, good, but the rest of you are like, what the hell? Where's this thing equal 0? Good. 2, -4. So 0 there and 0 there. A little z on there. Does this sound familiar? Alright, if it doesn't sound familiar, it doesn't make sense so far. We haven't really done much. So here's the idea. The only possible way that a polynomial function can change signs. Let me say that again. The only possible way, if a polynomial is going up positive, yay, what's the only way it can become negative is to first go through 0. So if I identify where those doors are, all I have to do then, if I plug in 0, if I can plug in 0, what kind of number do I get? Negative times positive. So I get a negative number in there, right? So it's got to be negative everywhere in there. Because what happens is it went through 0 at -4, and it goes through 0 at 2. It doesn't go through 0 anywhere in between, so it's got to be the same sign in that whole area. Does that make sense? It's almost too easy in one way. You're like, I can't make sense. It's too easy. So then you just keep going. Plug a 3 in, what kind of number do you get?
Positive.
Positive times positive is positive. And you plug in a -5, what kind of number do you get?
Negative.
Negative times
Negative. Positive.
-5 plus 4 is negative squared is positive. So you get negative times positive. It's negative. I like it. So filling this in should be relatively easy. And I want to point something out to you guys. If you don't quite get this shortcut, you can do exactly what we just did. We're going to go over this again in a lot more detail later. But for right now, you notice, see how it changes sign around 2? Mm-hmm. And what was the degree of this? 1st degree, right? Do you see how it does not change sign around that? And that came from here, and what's the degree?
2.
It's even. So odd roots, odd things, it will actually change sign around. Even things, it'll stay the same sign. It's an awesome possibility for a shortcut that it will do one more problem, and I'll show you. Now here you got to be careful. What's the answer
Greater than 2.
Yeah, good. So give it to me as a interval.
2, 2.
Of course, I just was so to be
Bracket?
not a bracket because I'm not allowed to equal 0. Good.
Can get really, really close.
How are we doing so far? Is that cool? Yeah, let's do one more of those.
So the even and odd powers where it changes sign, that'll work every time, all the time?
Every time, all the time. Isn't that crazy? So if I had this.
Oh, that's...
Please, we got nobody multiply that out, please. I hate that when somebody turns a test in. I didn't have enough time. Like, you multiplied all that shit out. Why would you do that? Don't multiply that out. It's factored for you already. Like that. That's good. So when you said your number line, what's going to go on there?
5 and
Five
-3.
and 3.
And?
0.
Good. 5, 0, -3. Put a little z, z, z. The reason I do that is because you could have something on the bottom and then you put a little u for undefined. So you know that won't be a part of any answer. In this case, every one of these is going to be a part of the answer because I want to know where is it equal to 0 for one piece, right? Okay, good. So here's the beautiful thing. I'm going to apply the shortcut. Shortcut kicks so much ass. Give me a number somewhere in here. 2. When you plug a 2 in, what kind of number do you get? Positive. Positive, good. Positive. Everybody with me?
Yeah.
So far. Now watch, here's the shortcut. You could just keep going. Plug a 6 in, plug a -2 in, plug a -1 billion in, whatever. What's it going to do around 0? Change. Done for that. What's it going to do around -3? Change. What's it going to do around 5? Stay the same. See, that's quick. Right? If you don't get the shortcut, then you can do it the long way. That's fine. Shortcut is because of the fact that what does a parabola do? At its 0, it turns. So it's not going to change sign. It's going to stay whatever sign it was. It's going to be down there or up there. What does anything to an odd power do? Go through. It's either cubish, right? Or it's a straight line going through. It's going to go through. It's going to change signs. That's why this is what's called the multiplicity. Right? It's a good movie with Michael Keaton, but it's multiplicity of the answer. So this 5 shows up with multiplicity 2. Since it's even, it'll actually stay the same sign on both sides. Yes, sir.
So why is it 5 and -3 if it's -5 and 3 after?
What makes it 0?
Oh, okay.
Yeah, so that's why it's always the opposite kind of sign. So don't forget, we're actually setting this equal to 0, so we're going to add the 5 over to solve it. So it's always the opposite sign of whatever's in there. Now, what's the answer? Here's where you got to be careful.
Negative infinity.
-3 to 0.
Less than or equal to 0. So not where it's positive, where it's negative.
So -3, comma 0, bracket.
And then
That's it.
U,
Good.
5 with brackets.
Why do I have to do that?
Why?
Because the question asks for where is it negative or 0. So it's 0 here, got those, and it's 0 there. Don't got that yet. See, that's where you got to be a little careful at the end. Equal to 0 or not, you might get some freaky little extra little dude at the end there, right? You guys kind of with me? A little tiny bit?
Well, can you repeat that one more time? I'm sorry.
Yeah. So I know I want to see where is it negative. So it's definitely negative in there. But I also want to know where is it equal to 0. Well, it's equal to 0 at the endpoints. That's why we included them, right? Is that it? Is that the only places it's negative or 0? No, it's 0 at 5 also. So you got to say or at 5. There's one point sitting in the middle of all this positive C. There's this little 0 dude going, shit. Don't forget me. Right. All right. You guys got it? Okay. Everybody's looking at the clock. Yes, sir.
Could you please explain that shortcut again?
Yes. Any odd power. What came from this? Which one of these zeros came from this? The 0. So since it's an odd power, it's going to change signs around it. It's going to go through. It's going to be a cubish kind of thing, right? It's going to go through. So if it's positive here, and we knew you have to still plug in one number to get it started. Then you go, okay, here it's going to change sign. Here it's going to change sign because it's, of course, that's an odd power, right? So it's going to change sign here. Here it's going to stay the same sign.
Oh, when it goes past it,
Yes, around it. So if it's positive on this side, it's going to have to be the same sign on the other side because it's an even power.
Okay, got it.
Now again, if you don't quite get the shortcut, you can still plug a 6 in, you'll get a positive. If you plug a -2 in, you'll get a negative, right? You can still do it the long way.
So like, when we have a problem like that, we're always expected to write the answer and do it from the bottom.
Good. It's got to be like that. Good. In that form. Exactly.
And what page was that?
This is section 1.7.
Do a bunch of ones.
Okay. 1.8, I'm not going to talk about a lot. That's just slope and distance formula and stuff. We did that, some of that earlier. Slope you should definitely know. 1.9 is a graphic calculator. I don't know if we're going to do the rest of that today. 1.10 is lines. MX plus B kind of stuff. Right, you should come in here knowing that stuff. 111 really don't focus on, so don't worry about 111.
We're not going to focus on 111 later.
No, not really.
Okay.
Yeah. So let me see. Okay, good. I like it. All right. So that's plenty. I won't get into chapter 2 yet. Whoa. Yeah, that's it. Finish that homework up. Quiz on chapter 1 will happen next Tuesday. So Monday is the last day to ask some questions for that quiz on Tuesday.
So today I realized I missed